My name is Julie Neilson. I am a research professor in the Department of Environmental Science, and I have always been interested in biology and science and understanding how living things interact and work. Specifically, I am an environmental microbiologist who studies soil system, and I'm very interested in soil health. And I worked in the Peace Corps when I was fresh out of college after my undergraduate degree. And I worked in Jamaica, I worked in Haiti, and I was very interested to see the creativity of subsistence farmers and maximizing the benefits of soils to help their plants to grow. And it got me very interested in the specific field of soil health and soil microbiology. What do those little microbes do in soils to help plants to grow? So that is where I ended up, and I went to graduate school when I was in my late 20s, I think, and I have stayed in the area of science research since then. We think of human health, and human health is having a balanced system where our organs are balanced and we have a human microbiome that is healthy. Well, the soil also needs to have a chemical balance, and it needs to have a healthy microbial population that enables nutrients to be cycled and become available to living organisms, whether plants or whether insects or other things. So microbes in the soil break down organic matter and release those nutrients to other living organisms. So that is sort of the cycle of soil health. Soils can also be toxic because they can have very low pH, so they can be acidic. And acid, just like it burns human skin, can burn plant cells and make it impossible for plants to grow. Soils can also have high accumulations of metals, which are from industrial activities, and that can make them toxic. So there's different aspects of soils which can be unhealthy. Either they're out of balance or they have toxic elements to them which need to be cleaned up. So one thing about being a professor and science is nothing is typical. So I used to spend a lot of time working in the lab. But as a scientist, as you progress through your career, you spend less time working in the lab, which I miss a lot, and you have graduate students who do a lot of the work in the lab. So I spend a lot more time advising and troubleshooting for my graduate students who are working in the lab, helping them to analyze their data, helping them to publish their data. But I do get to spend quite a bit of time out in the field sampling soils with my students and helping them design the experiments to address the questions that they want to answer. I also spend a lot of time writing grants and working with stakeholders. Outside of agriculture, I work a lot with the copper mining industry to try to recover degraded lands and get plants to grow on soils that have been disturbed by mining activities. So I spend a lot of time talking to copper mines and trying to help them or convince them to fund research in the area of land reclamation. Soil health has local, regional, and global implications. On the local level, we can look at agriculture. A healthy soil will produce plants with fewer inputs, and I think we all understand that organic agriculture is gaining in popularity, and the general idea among nutritionists is that plants that are grown organically might have better nutritional value, and all of that comes down to soil health. Less chemical inputs, more inputs from a healthy soil that is cycling nutrients. If I look at disturbed lands that are disturbed by industrial activities like mining, we really need to work on trying to recreate that soil balance that allows plants to grow in lands that have been disturbed by industrial activities. On a global level, the microbes in the soil are critical to the atmospheric balance of nitrogen, phosphorus, oxygen. I should take phosphorus out. Phosphorus is more in the below ground. Nitrogen and oxygen in the soil, carbon in the soil are all cycled through the soil. So I think you all know that through photosynthesis, plants fix carbon dioxide that's in the atmosphere into organic carbon. And then that organic carbon, when the leaves fall off of plants, goes into the soil. The microbes cycle that carbon, break it down, and release it back into the atmosphere as carbon dioxide. The same thing happens in the nitrogen cycle. 78% of our atmosphere is nitrogen, and yet that nitrogen is useless to all of living organisms. Our proteins in our body are made up of nitrogen, but we can't access it by breathing nitrogen. We rely on microbes. They're the only organisms that can fix atmospheric nitrogen into ammonia, which is the precursor to proteins. So really on a global level, we rely on a healthy, active soil to cycle nutrients through the atmosphere and through water bodies as well. In middle school and in high school is a perfect time to start to figure out what classes are easy for you, what classes are interesting, and which classes are really boring. Because that is when you start to realize your strengths. Are you really good at math? If you hate to write and you love math, then probably you should be thinking about a career that involves some kind of math. If math scares you and you love to write poems, you love to read, that's a good idea that maybe you should be headed in that direction. And so that has always been my advice to my own children and to my students, is to try to figure out what basic subjects you're most excited about. I first realized I was excited by science in 7th grade because I realized I loved the exploration and the investigative side of it. And I think that once you identify what you're really interested in, you don't need to worry about getting through the subjects that you're not excited about. You start to focus your school and your studies on what you're really excited about. And that will change. Maybe you'll realize down the line that what you thought you were excited about in 8th grade, you hate when you get to be a senior in high school. But keep asking yourself that question, what you're excited about and what you're good at. And then I think you'll feel fulfilled when you pick your career. What interests me most is that every individual feels that they could be a scientist if they want to. I think science can be intimidating to a lot of people, and I find that science is particularly intimidating to students who come from backgrounds where their parents might not be professionals. And so I have found that I really enjoy including a lot of undergraduate students in our research lab. And I think one of the advantages to that is our lab is fairly big. We have undergraduates, graduates, postdoctoral students, and the undergraduates get an opportunity to talk to the graduate students and understand what graduate school is about. And I have had a number of undergraduates who don't feel like they have the capacity to go on to graduate school in science. And sometimes that falls along gender lines or ethnic lines. I have a Hispanic student now who didn't think that she really could go to graduate school because her parents were not professionals. And as she got time meeting the graduate students, she became more and more excited, and she's entering a master's program in the fall. And so I think that getting that opportunity to be in a research lab when you're an undergraduate gives students the opportunity to think that they could do this if they wanted to. So I think that for me, that's the way I can increase the diversity. I won't say gender as much because there are a lot of female scientists now. I think that glass ceiling has partially been broken, at least at the graduate level. But I think in terms of ethnic diversity, that giving a broad spectrum of students the opportunity to work in your lab is a great way for them to feel empowered to go ahead to higher education if they want to.